Hello and welcome to another video. In this video, we're going to be working on count nice pairs in an array. And in the problem, you're given an array nums that consists of some integers, and you want to define rev x as the reverse of x. And you're asked to find all pairs of indices that satisfy the following conditions. I is less than j, and nums I plus rev nums j equals nums j plus rev nums I. So in this first example, there are two pairs. So it's 0 and 3 satisfy it, and 1 and 2. And in the second example, they tell you 4 pairs, but they don't really tell you which ones. Essentially, what we need to do is we need to kind of figure out, like, what does this really mean? And how do we find these quickly? So let's look at the first example. So we have numbers 42 and 79. And let's notice a few things about these, right? So let's see the difference between the number and its reverse. So the difference between 42 and 24 is 18, right? And 79 and its reverse, 97, is negative 18. And let's actually write out this formula right here, but let's move some variables around to see easier how we can get this. So we have nums I plus, let's actually type it instead, be easier. So there you go, nums I plus rev nums j equals nums j plus rev nums I. So now what we're going to do is we are going to actually move all the same terms to the same side. So we're going to have rev nums I over here, and we're going to have rev nums j on the right. So let's rewrite this. So we're going to have nums I minus rev nums I equals nums j minus rev nums j. So basically, we can say that for a number of pairs to be equal, that means for that number, let's call that k, right? For a number k, for that to be equal to some other number, right? For them to be the, whatever they call it, like the happy pairs or something, or nice pairs. Basically, these two values need to be equal, right? So nums k minus rev of nums k. Well, actually, we can even write it. We don't need to write it this. We can copy this, right? So we can say this is what needs to happen, right? So for a number, for numbers ij, for them to be equal, this is the case, right? So let's take our 42 and 79 again. So we'll say, nums I is 42 and nums j is 79. Now, these aren't the, obviously the indices are different. So this is really indices 0 and 3. So I is 0 and j is 3. Now let's take a look at this equation. So we're going to have 42 minus the reverse, minus 24, equals 79 minus 97, right? I think I screwed this up a little bit. Did I? Maybe I didn't. Oh, right. So that's what I'm saying. Okay. So this is not 90. This is not 79. This is 97. There we go. Okay. There we go. Now it makes more sense. So now we have 97 equals 79. So you can see, like here, 18 equals 18, and that's why these numbers are the same. Similarly, if you have numbers that are basically like a quote-unquote palindrome number, right, that are all the same digit, so like 11 and 1, let's try that. So we'll have 11 minus 11, and then this will be 1 minus 1, right? Like a palindrome number, quote-unquote. The reverse will be equal to the same number, so 0 equals 0. So basically, we can figure out this nums j minus rev nums j for every single number, right? So we can go through all of this for every single number, calculate it, and then bucket the numbers into those. So let's actually use that for example 2. So let's go, let's get the number minus the reverse, and the way we're going to do this, there's a few ways to do this. One of the ways is you can just make a new array, and for every number, get its difference and then sort. Or you can use a hash map, and then you don't need to sort, right? So one's going to be n log n, and one's going to be O of n with a hash map. So we'll do the hash map one. So let's actually get the difference, and we'll store as a key. So key equals difference, and value equals number of items. So every time we encounter a new element with that same difference, we'll add 1 to it. So here for 13, what's going to be the difference, right? So it's going to be 13 minus 31. It's like negative 18. Okay, so for negative 18, we have an item. Now for 10, it's going to be 10 minus 1, which is 9. So we'll have 9, we'll have an item. For 35, it's 35 minus 53, which is negative 18. So we're going to add another item over here. For 24, it's 24 minus 42, which is negative 18. So we have another item here, right? So we have 3 items so far with the same difference. And for 76, it's 76 minus 67, which is 9, right? Yeah. So there we go. Okay. So we have 3 numbers. Let's call it like A, B, C. And let's say A comes before B comes before C. It doesn't really matter. But we have 3 numbers with this same difference. So how many like pairs can we make, basically? So let's just say like A comes before B comes before C, right? So we'll have 3 indices with the same difference. Well, we can make AB, we can make BC, and we can make AC. Right? So we have 3 pairs we can make with this. And then when we only have 2 things, if we just have AB, the only pair we can make is AB. We can't do BA because remember the index matters, right? So like one of the indices has to come before the other one. So basically what this does, what this makes sure is you can't have duplicates. So if you use index 0 and 3, you can't use index 3 and 0. And the way we're going to ensure it is just say, okay, we're going to keep the order of like, we'll have like ABC or AB and so on. And like they have to come in this order, right? So this has 3 pairs right here. And this only has 1 pair. So we have 3 plus 1, which is 4. So now that we know, like, we can get this hash map and we can bucket everything, and then for each bucket we can figure out pairs. The question is, what's the best way to figure out pairs? 2 ways to do it. So let's say we have some number, right? Now our problem basically is given a number for how many or not really pairs, but how many numbers are in this bucket. We have to figure out how many pairs, right? So given count of a bucket, how many pairs is that, right? And this is basically a, so you can just use a n choose k, but there's an easier way to do it, and we're going to kind of see the easier way to do it. So let's say we have a bunch of indices like A, B, C, D, E that all map to the same bucket. What we're going to do instead is every time we have an index in that bucket, we can just reword this problem to saying, the number of pairs are just the number of combinations that end with each of these, right? So the number of combinations that end with A, the number of combinations that end with B, C, D, and E, and add all those combined. And I'll kind of show you how this works. So let's say we have some bucket of like, let's say the difference is 0. And let's pretend all of these are going to go in here. So we put in A. We'll have like a result variable. We'll first put in A. And obviously there are no combinations with just A, right? So our count's going to be 1 here where there are no combinations with A. Now we put in B. And we're going to say, okay, well, how many combinations can we make that end with B? And remember, the only ones that end with B, they can't end with B if they have any of these, right? Because you have to maintain, like, if you have I and J, the pair has to be in the format of I and J. It can't be J and I. So the only combination with B that ends with B is AB, right? So we have AB, which is 1 combination. Now we add C, and also our number of combinations here. So before, our number of combinations when we put in A was 1, right? So we can simply just take whatever we used to have and add that to the result. And that's how many combinations we have with this letter as the last one. So we can add 1 here. Now I'll kind of show you how this works. Now that we added B, now we have two total items in the bucket. So then whenever we add a new item, let's add we add C, how many combinations can we have that end with C? It's going to be 2. Because we can have AC and BC, right? So we basically take the previous count, and that's how many combinations you can have that end with this current letter. So you take the previous count, you add it to the result, and then you update the count. So now after we put in C, our count will be 3. Then if we try to put in D, we take our previous count, which is 3, add it to the result. It makes sense, right? Because we can have AD, BD, and CD. So that's 3 with this new letter, and now our total count is 4. Then if we add in E, take our previous count again, which is 4, add it to the result, and now our total count is 5. So we have 5 items total, but the number of different combinations we can make with all these letters is 10, right? So it's going to be like AB, AC, BC, all these 3 with D, and then all these 4 with E. So we don't really need to store the letter, we just need to store the count, right? So if we have like 0, 1, and we try to add another letter, we'll just say, let's take whatever the count was, add it to the result as the number of combinations, and let's just update it to adding one more. So that's how we can actually update our result without counting like a huge number of combinations. We will just take the previous count, add it to the result, and then add 1 to the count. And we'll do that. We could do that in like a one-pass solution, pretty straightforward. And then we just, they also ask you like if it's too big divided by mod. So we can do that as well. So that's basically the algorithm. It's just, we can like write down kind of what we need to do exactly. So calculate number minus reverse for each number, put or increment count of bucket, and when we do add previous count to result, right? So we take the previous count, we add it to the result, then we increment the count, and then at the end we just give the total. And that's pretty much it. So now we can code it up. So let's first make a function that gives you the reverse of a number. 2 ways to do this. You can just take your number, turn it into a string, and reverse it, or you could just actually make a function. So we'll just make a function. So we'll say def reverse number num. So we'll say result equals 0 while the number exists. So basically, in order to reverse a number, this is like a pretty common problem. What you need to do is you need to take your old result, right? You need to multiply by 10, and then you need to add the current digit from the number. So basically what's going to happen here is multiply by 10, add the current digit, which is just num mod 10, and then we have to divide the number by 10, right? So floor divided by 10. So quickly, just to show you what that looks like, let's say our number is 1, 2, 3. Let's say our result is 0. So what that looks like is in the beginning, the number exists, our result is multiplied by 10, and then we get our last digit in here, so this is going to be 3. Then we divide our number by 10, so we get 12. Then we multiply our result by 10, which is 30. And then we add the last digit, which is 2, so we have 32. Then we divide our number by 10. Then we multiply our result by 10, add the digit from this, and now our number is 0. So we reversed 123, got 321. So that's how you do basic reverse, and I think there's like an easy problem that's like reverse a number or something, or maybe you didn't medium, but not too bad. Anyway, so now we return the result. We have our mod function, or just our mod value. So as always, then we have our counts, which is going to be default dict. Int. We have our actual result, like our combinations total. We can call this like even like pairs maybe if you want to. And for num in nums, let's get that difference, right? So what we want to get is num minus reverse number num. So we'll say difference equals num minus reverse number of the num, right? Because remember, it's the number minus reverse number num in the thing that we need, and then we need to compare this for every single number. So we get it. We check if it's in counts already. So we can even do this, actually. We can just say pairs, because it's a default dict, we can say plus equals counts diff, right? If it's not in there, it'll just give us 0. So give us the previous count, add it to the result, and now let's add 1 to the count. So counts diff plus equals 1. And finally, let's return result mod. So the basic thing to look for, I guess I forgot to mention it, is because our constraint was 10 to the 5th, we couldn't really do something DP most likely, so we couldn't have like an n-squared solution. So immediately you want to look for some kind of like traversal or sliding window or 2-pointer, and we basically found a traversal that worked. Okay, so let's try to run this. Probably misspelled it, yeah. Default pairs. Okay, let's see what happens here. All right. So we have a reasonably efficient function. Let's go through the time and space. So to reverse a number is going to be something like log n of the number, right? So the numbers are 10 to the 9th, like as big. So this is going to be like n times log of the size of the number, I guess. So this is going to be like this is log base 10 as well of the actual number, right? So for every number, we have to reverse it. So it's log base 10 to reverse a number because you are reversing digit by digit. So if it's 10 to the 9th, you have 9 reverses. Yeah. And then basically we get these differences in place, and the rest of it is just in place, right? So we are basically traversing, we are using a hash map, and we are doing everything else like right away. So this is just basically this. So it's O of n plus log 10 of the number, because traversing a number is not a constant time operation. It depends on the number size. Okay. But I mean, that's basically going to round to a very small number because, you know, the number length, or sorry, this is going to be like, you know, for a number 10 to the 9th, it's only going to be 9, right? Which is like almost nothing. So really, worst case scenario, we have like 9 times n or something, which is totally going to pass. Space. So they're like, we have to figure out how many differences are there. And I guess worst case scenario, every key is unique. So it would be like O of n, right? Where like we would basically have every single number would have a different difference. We'd have no pairs, but every single key would be unique. So then it would be O of n space. If every key was unique, you would store it in the dictionary. And yeah, I believe that's all for this one. So hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.